Hey there, in this video we're gonna do a little bit of analytic geometry in circles mainly. So what is analytic geometry? So you may have wondered that if you've heard that terminology. And so what analytic geometry is, essentially it is the idea that if a geometric curve can be represented by an algebraic equation, then the rules of algebra can be used to analyze that curve, which is pretty cool. So if you think of different things that you see in geometry, triangles, squares, rectangles, although those are not curves, right? But if you think of then a circle, that's a curve. So a rectangle or a triangle, we can't represent it by just a single equation, but a circle we can. What other things can we represent by a curve? Ellipses, hyperbolas. So those are things that we will use in analytic geometry. So we can take a geometric curve or figure and represent it by an algebraic equation, and then we can use the rules of algebra to talk about what's happening there. So a circle, just to remind you of the definition from intermediate algebra, is the set of all points that are the same distance. I meant to say the same distance, and then I changed it to equidistant from a fixed point, the center of the circle. So that fixed point is called the center of the circle. So equidistant means the same distance. And the fixed point is the center. So for example, say we wanted to find the set of all points that are a distance of 2 from the point 3, 1. So find all points that are a distance of 2 from 3, 1. From 3, negative 1, actually. So how would you find that? I'm going to try to sketch it. So if we go to the point 3, negative 1, so this is the fixed point. And so we want to find all points that are a distance of 2 from this point. Well, I can go up 1, 2, and that will put me at some other value. I can go to the right 1, 2, I could go to the left 1, 2, I could go down 1, 2. And so these 4 points are a distance of 2 from the point 3, 1, right? 3, negative 1. So this will be the point 1, negative 1. What will this one be? So if we were at negative 1, we went down 2. The 3 stays the same, so it'll be negative 3. And then here we stay at 3, the x value, but we went up 2. So from negative 1 up 2, it will be 0 and then 1. So all these points, these 4 points are a distance of 2, but are those the only ones? No, right? There's going to be, I can have points all along here, and so that's what creates the circle. Normally I like to draw my circles first and then put the center and the radius, but bear with me as I draw this thing. So this will be, so that's what a circle is. What creates this curve is that all those points are so close together that you can't even distinguish that they're points. It just looks like a nice curve. And so this is the circle is the set of all points that are the same distance from that fixed point. And so this is what we call the radius. So the radius is 2. And the center is the point 3, negative 1. So how do we write the equation of a circle then? So from here, I can go, well, if I can represent any point on the circle, so say that's the point xy, then I can use Pythagorean theorem or the distance formula. So the previous videos that I shared with you will have talked about the distance. And so here, I'm going to have, well, what is this distance? Right, and this is the point x, and this is the point x equals 3. So the distance is the absolute value of x minus 3. And same for y. So for y, This is the point y over here, right? And this is the point -1. And so the distance here is the absolute value of y minus a -1, which is the absolute value of y plus 1. And r is the hypotenuse of this right triangle. So I can use Pythagorean theorem, or you can think about the distance formula. So using the distance formula from the center of the circle to the point xy. So I'm going to have r squared, right, the distance, the hypotenuse, is equal to the x minus 3 squared, this quantity, plus the y. So y plus 1 squared. Since I'm squaring it, I can get rid of the absolute value, and therefore, and so this becomes the equation of our circle, right? If you're doing it with the distance formula instead of the Pythagorean theorem, then I will say from here, I will say r is equal to the square root of x minus 3 squared plus y plus 1 squared. And then when you square both sides, you get back to that point. So in general, the equation of a circle is, that should say circle. It looks like a D. Is you're going to have x minus h squared plus y minus k squared equals r squared. And this gives you the center, just as was over here, 3, -1. So the center here will be hk, and the radius is r. Notice that here we had to square the r in the Pythagorean theorem, but just that length is r. So r is equal to the radius. So let's try some examples. Let's determine, let's say, find the center and radius of the circles. So I'm going to write them down, and you can pause as you think about one and do it on your own, and then unpause to see what the solution is. So x minus 1 squared plus y minus 4 squared equals 25. So I want you to find the center and the radius for this. So go ahead and pause, do it, and then come back. So noticing that remembering that the equation of a circle is x minus h squared plus y minus k squared equals r squared, we can compare what we have. And so it looks like the center is 1, 4. Notice as this have a minus, so in these also both have a minus, so then I just take, just like here, the hk, so I'm just going to take the 1 and the 4. And what's the radius? The radius is whatever you're squaring to get 25. So what are we squaring to get 25? 5. So the radius is 5. You can also think of it as r squared equals 25, which means when you square root both sides, r is going to be equal to 5. Remember that r is a distance in this case, so we don't worry about the plus or minus because distance is positive. So what about the second one? Same thing, find the center and the radius of the circle. I'm going to write it down, pause it, do it, and then come back and look at the solution. So x squared plus y squared equals 8. What is the center and what is the radius? So comparing it to our general equation of a circle, right? Notice that here, this says x minus h squared, but here I only have x squared. Well, you can think of this as x minus 0 squared plus y minus 0 squared equals 8. And then it's easier to see, oh, okay, the center is 0, 0, and the radius is whatever I'm squaring to get 8. And this is a little bit harder to see because 8 is not a perfect square. So I might want to do this method instead. So I can say, well, r squared is equal to 8, which means that r is the square root of 8. And now I can simplify this. So r is 2 root 2. And so that's my center and my radius. Let's try another one. What about x plus 2 squared plus y squared equals 9? So same thing. What's the center? What's the radius? Go ahead and pause. Do it on your own. Come back. So here, notice that our equation, right, is x minus h squared plus y minus k squared equals r squared. And this gives us the center is hk and the radius is r. So these have a minus, but that has a plus. So what does that mean? You can rewrite this as x minus a minus 2. And now I can see, oh, okay, so my center is negative 2, comma, and that is 0. And the radius is, what am I squaring to get 9? 3. When this number is already a perfect square, it makes things nicer for us. When it's not a perfect square, like here, like 8, then it's still okay. It's just we're going to get an irrational number, and that's fine. Things don't have to be always pretty. All right, so let's try a different kind of example. So let's find the equation of a circle with diameter endpoints of -1, 3 and 7, -5. So what is the diameter? Diameter is that line segment across the whole circle, right? And it has to go through the center of a circle. So let me go back up to where I had a circle drawn. So if in this circle, the diameter, I can go, as long as I go from one end of the circle going through the center and then over, this will be the diameter. Which is usually twice the radius. Well, not usually, it's always twice the radius. And so that means that to find the equation of the circle, if we know the diameter, then the diameter is twice the radius. So that means that then the radius is half the diameter. So I just need to find the length of the diameter and then divide it by 2. How do I find the length of the diameter? We're going to use the distance formula. And then the center, notice back up over here that the diameter goes through the center. And in fact, the center of the circle is the midpoint of the diameter. So to find the center, I need to find the midpoint. And so the center is going to be the midpoint of the 2 points. And hopefully you watched the other videos that I posted. And so the midpoint, just to refresh your memory, right, is you have x1 plus x2 divided by 2 is essentially the average of the coordinates. Okay, so let's do this problem out. I'm a big fan of pictures, so I'm going to try my best to draw what this looks like. So my endpoints are -1, 3. So I'm going to go 1, 2, 3. So that's one endpoint. And then the other endpoint is at the point 7, -5. 7, -5. Now drawn to scale. So this is going to be the diameter. And so that means that I have a circle somewhere in here. I'm not even going to attempt to draw it because it's going to be ugly. So if you dot it first, it comes out better. So there's your circle. And you can already see, okay, so if this is the diameter, my center is going to be somewhere over here in the middle. So the center is the midpoint. So let's find it. So the midpoint, like we said, is the sum of the average of the two endpoints. So let me scroll up so I can see my endpoints. And so I'm going to have the x ones first. So -1 plus 7 divided by 2, and 3 plus -5 divided by 2, which becomes, what's that? 6 divided by 2 is 3, and 3 plus -5 is -2 divided by 2, that's -1. And does this seem reasonable? Always ask yourself, does something seem reasonable? So let's go back to my not so pretty graph here. Actually, that's pretty on point, so I guess it's not that bad of a graph. Notice that there's 3 and there's -1, and so that seems to make sense. So now I have the center. So in the equation of my circle so far, right, the equation is x minus h squared plus y minus k squared equals r squared. So from this equation, what I just found are my x and my y coordinate. So my x coordinate was the 3, so x minus 3, and the y coordinate is the -1, so y minus -1. So I need to find the r square. So r square is, well, r is half the diameter, the length of the diameter. So let's find the diameter. The diameter is the length of this line segment. That's the diameter. So we're going to use the distance formula. So it's going to be the square root of, and let's remind ourselves, what were the points? This was 7, -5, and this one was -1, 3. So the distance is the change in the x's, right? So 7 -1 square plus -5 minus 3 square. And so as you do this, 7 minus a minus becomes plus. So I get 8 squared is 64. -5 minus 3 is -8 squared. That's 64 again. So this is the square root of 2 times 64, right? 64 plus 64 is 2 of them. But I know the square root of 64 is 8. So this is 8 root 2. So that's the diameter. So the radius is half the diameter. So that the radius is 1/2 8 root 2, which is then 4 root 2. And so I can go back and put it in here. So I can finish up the equation of the circle. So the x minus 3 squared plus y plus 1 squared, right, minus a minus, equals r squared. Well, this is r. R equals 4 root 2. What's r squared? Square them, so I get 16 times 2, which is 32. So this would be the equation of our circle. So this is why it was really important to learn to review our midpoint and distance formulas. Let me know if you have any questions.